We are converting the chapter pressure into the form of question answer, and this is part 3. Now let's continue. This is question number 18. What is hydraulic lift? And how can we answer and what is the answer? Hydraulic lift is a device based on Pascal's law which magnifies the force, and it is used to lift vehicles in the hydraulic garages. Probably you have seen this in motorcycle garages or car garages. Okay, let's go to another question. Question number 19. With the help of the given diagram, answer the following questions. Now, diagram should be given. It seems to be very big diagram. Okay, now let's go through question. Question is, which device is shown in the diagram and on which principle the device works? This is hydraulic lift. That's why the answer is, it is hydraulic lift. And it works on the principle of what? Pascal's law. Okay, now let's go to another question related with the same diagram. What are X, B1 and B2? Where are they? Look at this. Here it is X. Now B1 is here and B2 is here. And certainly X is reservoir. And this V1 and V2 are valves of this hydraulic lift. Okay, let's go to another question. In the given diagram, V1 is closed and V2 is shown to be opened. In which condition it happens while using this device? During the use of this device, write down which region. Now again we need the device, that's why I'm showing the device again. And the question is, V1 is closed here, it is shown closed, and V2 is not closed, it is opened. And in which condition it happens is our question. Now it's very simple. When we apply force on this small piston, it exerts pressure in this liquid, and the same pressure transmits to both the side, reservoir side and towards this big vessel also. But because of the pressure of liquid, V1 remains closed because it cannot open towards this side, left hand side. It is designed in such a way that it can open towards right hand side only. That's why this pressure closes the valve V1, but the same pressure opens the valve B2 and liquid flows towards B2. So we have to write answer this way. When a small piston is pushed downward, then it exerts pressure on the liquid. Liquid transmits the pressure on both the sides, that is towards reservoir and big vessel, but the liquid pressure acting on V1 cannot open this valve towards reservoir. On the other side, liquid pressure acting on V2 opens this valve towards big vessel because valves are designed to open only on one side, like the door of our houses. This is our answer. Okay, next question. Write down the function of a stopper. How it works. Look at this, stopper is at the bottom side. When it is open, certainly the liquid flows towards this reservoir. Yeah, and that's why we have to answer this way. Stopper is used to bring down the vehicle raised by the big piston back to its original position. When stopper is opened, liquid flows from big vessel to the reservoir because liquid flows from high level to the low level unless the level is equal. Hence the vehicle placed on the big vessel comes down. This means the stopper has a great function. What it is, whenever the vehicle is raised by this big piston, and it has to bring back to downward direction when work finishes on it, and at that time we'll open the stopper. Okay, let's go to another question. This is question number 20. Study the given diagram and answer the following question. Question is, first we have to see the diagram. This is a diagram. A hydraulic press is shown, and here two pistons are shown. They are A and B, and force is applied on a small piston and load is raised from the big piston. Okay, now the question is, what is the name of this instrument? We can answer very easily. This is hydraulic press. Second question, on which principle does it work? State the principle. Now what the answer? It is based on Pascal's law. According According to Pascal's law, pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. It was answered in the previous class also. Okay, now next question is the cross section area of piston A and B is 20 centimeter square and 0.4 meter square respectively. How much force can lift piston B if 240 Newton force is applied on piston A? Now we have to find out the value of load. This is a numerical problem. At first we have to write the information and then we'll use equation to solve it. Informations are area of piston A, which is normally represented by A1, is equal to 20 centimeter square. Another information is area of piston B, A2, it is also given in the numerical, it is 0.4 meter square. Either we have to convert this meter square into centimeter square or centimeter square should be converted to meter square. We must have the same unit. How can we convert this meter square into centimeter square? By multiplying it with 100. Since we have 2 meters, that's why we have to multiply by 100 twice. And each of the meter converts to centimeter. Whenever we have to convert a bigger quantity into a small quantity, then we have to multiply the number with the relation. A meter and centimeter are related in such a way that 1 meter has 100 centimeter. That's why here we have 2 meters. That's why each of them can be converted into centimeter by multiplying it with 100 twice. And our result is 4000 centimeter square. Now next information, force on the piston A, that is represented by F1, this is equal to 240 Newton, and force on the piston B we have to find out, that is represented by F2, and this is question mark. Now which equation we are using? It's very simple. We have this equation, F1 by A1 equal to F2 by A2. F1 by A1 means pressure on the small piston, F2 by A2 means the pressure on big piston. In both the side pressure is equal, that's why F1 by A1 equal to F2 by A2. Taking the value, F1 its value is 240 Newton, A1 its value is 20 centimeter square, and F2 we have to find out, A2 is 4000 centimeter square. Now we can calculate easily. F2 is equal to 240 Newton multiplied by 4000 centimeter square, and it has to be divided by 20 centimeters square, and the result, final result is 48,000 Newton. This is a huge force. So for our answer we have to write one sentence, that means therefore 48,000 Newton can be lifted if 240 Newton force is applied on piston A. Let's go to another question. 21. With the help of the given diagram, answer the following questions. The diagram is given here. Here 3 objects are shown. One is floating, another is suspended, and another one is sinking. They are named as X, Y, and Z. Now the question is, which object displaces water equal to its own weight? Give reason. Certainly X and Z displaces the liquid equal to their own weight. Now how can we answer? X and Z both displaces the weight of water equal to its own weight. The reason we can write like this, X is floating. According to principle of flotation, weight of a floating body is equal to weight of displaced liquid. Since X is floating, so its weight is equal to the weight of displaced water or the weight of displaced liquid. Okay, now another part, Z is suspended. It means upthrust of water is equal to the weight of the body. According to Archimedes' principle, upthrust is equal to weight of displaced liquid. So, weight of the body, Z, is equal to the weight of displaced water. Okay, now let's go to another question. Write density of Z object in SI unit. The density of Z object is equal to the density of the liquid, because if a body is suspended in certain liquid, then its density will be equal to the density of the liquid. That's why we can answer this way. The density of water is 1000 kg per cubic meter, so density of Z is equal to 1000 kg per cubic meter. Let's go to another question. A man sits on a chair having 4 legs, each equal area 10 centimeter square. If his body mass is 75 kg, calculate the pressure exerted on the ground. Now we have to write first the given mass of that man, which is represented by small m equal to 75 kg. An area of 4 legs of chair, that can be represented by A, is equal to 4 into 10 centimeter square, because each of the leg has the area of contact with the ground is 10 centimeters. Now we are going to calculate pressure. Pressure is calculated in Pascal, and Pascal means Newton per meter square. So centimeter doesn't work here, and so it has to be converted into meter square. If a small quantity has to be converted into bigger quantity, since the relation between meter and centimeter is of 100, so we have to divide this quantity by 100 twice, because each of the centimeter has to be converted into meter. So I am dividing with 100 twice, and the result is 0.04 meter square. Pressure P is the question. Now how to solve this? This is a very simple equation. Pressure equal to force by area, but force is missing. So in place of force we have to use m into g. M into g means weight force. W equal to m into g, or force equal to m into g. M into g divided by A. Now m we know 75 kg, and value of g, average value of g is 9.8 meter per second square. We must know this. And area is equal to 0.04 meter square. Now after the multiplication and division we will get the answer. Therefore pressure is equal to 18,375 Pascal. This is our answer, and it will be better to write a sentence for the answer at the end. Therefore pressure exerted on the ground is 18,375 Pascal. Let's go to another question. What is upthrust? When a body is placed in a liquid, then liquid exerts force from all the sides. The resultant of this force always acts in the vertically upward direction, which is upthrust. So we have to answer this way. A resultant force acting vertically upward on a body when placed in a liquid is called upthrust or buoyant force. Upthrust is also called buoyant force. Okay, next, what are the factors on which upthrust depends? There are certain factors. Upthrust depends upon: number 1, weight of the displaced liquid; number 2, density of the liquid; number 3, volume of the body immersed into the liquid. Remember this: weight of displaced liquid, density of liquid, and volume of the body immersed into the liquid. Okay, next question. The water tank is kept at some height. Why? Always we keep water tank at certain height. What is the reason? The reason is liquid seeks its level. It means it always flows from high level to low level unless its level becomes equal. Moreover, pressure of liquid is directly proportional to the height of the liquid. If height is more, pressure will be more. So, water tank is kept at some height to flow it towards lower side with pressure, due to which water can be obtained from the tap kept at the lower side. Next, state law of flotation. Name a device based on this law and mention its use. According to the law of flotation, a body floats only when it displaces the liquid equal to its own weight. Hydrometer is based on the law of flotation, and it is used to measure density of liquid. 27. Why it is easier to pull a bucket of water from the well until it is inside the water but difficult out of water? This is very common experience of our daily life. We can answer this way. Fluid exerts an upward force, that is upthrust, on the body immersed partially or completely into it. Upthrust is the force which reduces the weight of the body. Since upthrust of water is very high than the air, so weight of the water filled bucket is less in water than in air. Therefore, we feel easy to pull the bucket in water but difficult in air. Okay, next question. Among two bodies A and B, which one experiences more upthrust? And now we need the figure. Write down with reason. We have to give reason also. This is the diagram. And how can we answer this? Certainly A experience more upthrust. How to write answer? This way. A will experience more upthrust because upthrust depends upon the weight of the displaced liquid. Volume of A is greater than volume of B. So A displaces more water than B. Therefore, the weight of the displaced liquid is more by A, hence it experiences more of thrust than B. This way we can answer. As shown in the diagram, a body is first dipped into water and later into the saturated solution of salt, in which case the body experiences more of thrust. Give reason. Now, this is our diagram. A body is first dipped into water and again it is placed in saturated solution of salt and again it is sinking. Now, how can we answer the question? This way, in second case, that is in case of B, it will experience more of thrust because of thrust is directly proportional to the weight of displaced liquid. In case of B, the same volume of saturated solution displaced by the body has more weight than the same volume of water in case of A. Hence, the upthrust is more in case of B. Okay, next question. Compare upthrust acting on the egg and weight of the egg in the following condition. Here is the diagram. In each case, we have to compare the weight of egg with the upthrust acting on the egg. Now, how can we write the answer? Is very simple. In first case, in case of A, weight of egg is greater than the upthrust exerted by the water on the egg. That's why the weight is more, so it is sinking. But in case of B and C, upthrust is equal to weight of the body. That's why it is floating, but floating differently. But in both the cases, the object is floating. And so, upthrust and the weight of egg is equal in both the cases. So, we can write this way. In case of both B and C, weight of the egg is equal to the upthrust. Okay, this much for today. I'll meet with you again in another class of the same chapter, pressure. Okay, this much for today.